لا، انا كده المفروض انت بادئه الريكورد، ممكن تفصلي وبعدين تفتحيه تاني اول ما تبداي البرزنتيشن افضل. تمام.
I'm gonna start now.
طيب.
Okay, good afternoon. That's Mrs. OLA ELGHERIANY. I'm gonna be teaching you science checkpoint, the new syllabus 0893. So I have 13 years of experience in IGCSE and checkpoints. Hopefully I can help you to the maximum. As you all know, the science checkpoint, again, the new code is 0893. So the papers are totally different than the old syllabus. And it's divided into three main points, okay? It's divided into biology, chemistry, and physics, and definitely earth science. But the papers are focusing on the three science branches, biology, chemistry, and physics. Included in every section, we have investigations and critical thinking questions. So related to any lesson, we will be practicing also on scientific thinking and investigation and experiments. So lately, what happened in Cambridge, that the exam is held only on stage 9 book. So you are getting prepared in stage 7 or in grade 7 on stage 7 and 8 book. And then in grade 9, you are taking stage 9 book. You know, we have in checkpoint 3 books, but the exam is coming at the end on stage 9 only. And the exam is coming 2 papers. Every paper is for 50 marks. The 50 marks, we write them in Cambridge in 45 minutes, which means that we need to practice a lot to be able to reach this level and to finish the paper. In every paper, scientific investigations are part of the paper, in addition to theoretical questions. We do not have multiple choice questions in checkpoint exams. How I'm going to be working with you, inshallah, I'm going to be working on 3 lessons weekly, one for chemistry, one for biology, and one for physics. Earth science is going to be part of our physics structure, and the lesson is for 1 hour. The first lesson I'm going to start with is the atomic model. And the points we need to know or learn out of this lesson, and you need to make sure that you understand those points to be able to define what is the atom. This is number 1. You need to know who discovered the atom and the atomic structure. This is very important to be able to draw the atomic structure and to make electronic configuration, as well as to be able to draw the first 20 elements in the periodic table. Okay, so those are our lesson objectives for today. Yes.
هي لو عايزه تاخد تبدا في النقطه اللي هي تاخد فيها ايه.
I don't know what happened, but okay. So let's start our lesson today by asking you a very small question. What is the smallest building unit of a human body? If you kept thinking about that, most probably all of you are going to tell me the cell. The idea of asking this question, that there are a lot of students have the misconception between the difference of a cell and an atom, which is our lesson today. Our lesson is about atoms. So students do not understand, is an atom is a living thing? What is the difference between cell and an atom? So definitely there is a difference. The cells are the building blocks of the human body, okay? So they are part of the living organisms. However, the atom is the building block of matter And matter in chemistry, it's everything around us. Solid, liquid, gas. And you can give me examples for that. Okay, so this is the atom. So students will ask me, does this mean that we have atoms inside our body? Yes, we have atoms inside our body because our body is a complex structure and it has a lot of chemicals. But those atoms inside our body do not make our body. Cells make our bodies. And as you studied in biology before, group of cells make a tissue, group of tissue makes an organ, group of organ makes an organ system, and then organism. So the cells is about in biology. Don't get confused. It has nothing to do with chemistry. Today, we are going to study the atom, that it's the building or the smallest building unit of matter. We cannot break it. We cannot see it even. Group of, as you can see here, the first picture, this picture, is showing us the atom. And definitely you can recognize from this picture that there is a center here, and there is things that is revolving around the center. Group of atoms like this one makes something called a molecule. So a molecule is a group of atoms joined together. A group of molecules is going to make a matter at the end. Let's go deep and see how can we understand the atomic structure. I wanted to look deeply in these two pictures and say what is the common between the two pictures. I wanted to look deeply on these two pictures and have a look and tell me what is common between the two pictures. On the left side, we can see the solar system. The sun is in the middle, planets are revolving around it. While in the second picture we are studying today about the atom, we can see a center. Also, we can see positive charge. We don't know what is that. We can see electrons. They wrote here electrons for us. The blue parts are electrons. So if you just thought deeply about it, you will find that there is something common, that there is a center, and there is something that is revolving around it. So my next question for you, I will ask you, what makes the planet keep revolving around the sun like that? And they don't escape the orbit, for example. They don't go away, they don't fall, they don't... How do they keep orbiting the sun like that? Excuse me? Okay, so yes, I'm sure that you know that what keeps the planets revolving or orbiting the sun like that, it's their gravitational forces. The gravitational and the attraction forces acting from the sun, okay, towards all the planets. The same thing is happening in the atom. The atom has a center, and this center has a very strong attraction force due to those positive charges. So this attraction force grabs all the electrons to it. And that's why the electrons keep revolving in orbits around the nucleus. So this is the similarity between the atom and the solar system. And you have always to keep thinking critically and deeply. What are the similarities and differences between anything you are studying, between any two things you are studying? So as we understand from here, we have the atom. It has a center. This center has a positive charge. It's called the nucleus. And around the nucleus, we have electrons revolving in orbits. Who discovered the atom? This is a very brief idea about it. The atom, it was not, from the beginning, it was not this structure. They did not reach this structure from the beginning. We had a lot of scientists who came and made the work on that, starting from Dalton. He just thought that the atom is just a ball like this. Then came Thomson, introduced to us the plum pudding model, and he said, no, Dalton is wrong. And it's a plum pudding model. It's formed of positive and negative charges. But came Rutherford, and he did a very smart experiment. It's called gold foil experiment. And he said, no, the atom is not a ball with positive and negative charge. However, it's a center, and around this center, there are particles moving. But he was not able to determine what are those particles. Who was able to determine those particles, he's called Bohr, and this is the atomic structure we are using nowadays, Bohr model and the quantum mechanical model, which introduced to us that there is a nucleus in the center, electrons are orbiting it in a place or an area called an electron cloud. And this what came with the quantum mechanical model, that there is a space around the nucleus where there is a probability of finding any electron. So this is a quick history. There are not a lot of questions coming on this part. It was part of the old syllabus, but it's always good to have an idea what you are studying. So let's watch this video and make some comments on it. As you can see here, you found the atom. As I told you, there is a nucleus in the center. And this nucleus, as you can see, it's consisting of two particles, one red and one yellow. It's written here that the yellow is called neutron and the red is called proton. And there is outside of the atom, there are electrons revolving, which are carrying the negative charge. Let's complete. Okay, this is a very important point that we have in nature. There were discovered 118 elements. Scientists discovered them, elements around us. Those elements, they don't have the same number of protons, electrons, and neutrons. Definitely, they are different. What I wanted from this video right now, I wanted to show you this huge table, which we call it the periodic table. And it's coming in the second chapter. And we are going to study all the trends in this periodic table in details and all the properties, chemical and physical properties as well. For the not for the 118 element, but mainly for the first 20 elements in our periodic table. We will learn about the reactivity, their physical properties. But right now, what I just want you to know that the atom that we are studying right now, it's part of this huge periodic table. Every element here is represented by an atom, is represented by its chemical symbol for this atom. And every atom has different number of protons, different number of electrons, and different number of neutrons. This is the most important thing I want you to come out from this video. So this is my first atomic rule. We are going to write together the atomic rules after this video. The first atomic rule is that the number of protons are equal to the number of electrons. This is a very important rule. The positive charges are equal to the negative charges. I want you to focus very well on this part and tell me what are we doing exactly. Okay, so as we were here, we have two numbers in every atom. We have, yes. So as we can see here, we have two numbers. The first number is the atomic number, which is the number of protons and the number of electrons. And the second number is the atomic mass, or the mass of the atom. Okay, let's move here. This is what I wanted you to get from this video. And here are the atomic rules that I'm going to share with you now, and that they are very important. In all the chemistry, you are going to use those rules and they will not change. The first rule is that the number of the electrons are equal to the number of the protons. This will never change, put it in mind. Okay, in our drawings, in the bonding in unit 2, we will always use that. The second rule is that the atomic number refers to the number of protons. So when I tell you that I have an atom that has an atomic number of 9, which means that, definitely are going to think about it. This means I have 9 protons? Correct. Does it mean that I have 9 electrons? Yes, correct. Excellent. But does it mean that I have 9 neutrons? No, it doesn't mean like that. So it only means that I have 9 electrons and I have 9 protons only. But what about the mass number? As you can see here, the mass number is the number of the protons and the neutrons inside the nucleus, as you can see here. So this is the mass of the atom. And definitely you can see now that the mass of the atom is concentrated in the center here. I want you to guess why the mass of the atom is concentrated here. We are having questions after that, and I want you to think about that deeply. Why the mass of the atom is concentrated in the center? So don't forget the 3 important atomic rules that are gonna help us to work easily. I want you to see this one. This is exactly how the atom looks in reality. It's not orbits and lines and we are drawing it like that. No, it's just a space around the nucleus. It's called an electron cloud. So this is how it looks. And this is how it, 1 second. This is exactly how they move. The electrons are moving an electron cloud around the nucleus. Okay, this is the reality. But they are making for us, it's easier. They are making the atomic structure easier for us in drawings. That's why we are using the Bohr atomic model with the orbits. Hope it's clear for all of you. So now, the very important question, I want you to think why. Why the mass of the atom is concentrated in the nucleus? If you went back to this one, a smart student is going to tell me, Miss, in the center, there are protons and neutrons. And definitely, they are 2 particles, so their mass is much more bigger than the electron. Smart student would tell me this. Correct. Another student would tell me, but Miss, electrons also have mass. Why are you neglecting it? A very good question. We are not neglecting the electrons. We love electrons, but electrons' mass are very small. Electrons' mass is very small, and that's why we are neglecting the mass of the electrons. However, the mass of the protons and the neutrons together is very big, and that's why the mass is concentrated in the center. Again will come a very smart question. They will ask us why the nucleus is positively charged. I want someone is awake from the beginning of the lesson to tell me why the nucleus is a positively charged here. Why it's positively charged. Definitely, I'm sure there is a smart student sitting right there, know the answer. Yes, it's positively charged because the protons are positive, while the neutrons, they have no charge, haram. So that's why the nucleus is positively charged. I always teach this to my students as PP, positive protons, NN, neutral neutrons, and Ne, negative electrons. So the electrons are always negative, protons are always positive, and neutrons are always negative. Neutrons have no charge, or we can call it neutron. Now, as you can see here, this is a very important part. As I told you in the beginning, drawing the atomic structure is very important, and we have rules for that. So as we saw in the video that every element has two numbers, it has the mass number and its atomic number. What we use for drawing is the atomic number, which is the smaller number. I'm going to give you small hints and small secrets of the periodic table. I always have for every element two numbers. Here in sodium, it's 23 and 11. Always, 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 the small number is the atomic number, and this will never change. And always the big number is the mass number. Don't forget this note. So how do we arrange our atoms? As you can see here, you will find 2 electrons in the first energy shell, then 8, then 1. Why is that? This is our rules. This is called an octet rule. In octet rule, the maximum number of electrons to be in the first energy level is only 2. This is the center. Those are the energy levels. So the maximum in the first energy level, only 2 electrons. Okay, this is my maximum. Right. What about the second energy level? The second energy level, the maximum number of electrons are 8. What about the third energy level? Honestly, the correct thing is 18 and 32. And this you are going to study it in AS chemistry when you move forward to the A levels. Right now, because you are only required to know the first 20 elements, so we are using only 2, 8, 8, 8. So this is what we are using as electronic configuration. So the question now, I want you to draw, one second. I want you to draw the magnesium atom with the atomic number 12 and the mass number 24. And you are going to follow the 2, 8, 8, 8. So there is someone who is going to ask me, Miss, what is that? What do I have to do? I don't understand anything. What are you saying, Miss? Definitely, I know that. Okay, so we are going to think. So here, let's see how we are going to do this. I have 2 numbers. Definitely, I'm going to use the 12, which is the atomic number. We use the atomic number for drawing. So for the magnesium, you are going to use the help of the periodic table. Okay, and you will find out that magnesium symbol is Mg. And when we come to draw it, we put the positive nucleus. And then we start to distribute those electrons. They are 12. So in the first energy level, we put 2. In the second energy level, we put 8. Why I am doing that? Because I'm following the rule. And we draw it like this. And in the third energy level, we put the remaining electrons. Definitely, your circle can be better than mine. It's going to be 2. So now, this is a correct drawing for magnesium. My electronic configuration for it, it's 2, 8, 2. From where this electronic configuration come again, I'm going to take the atomic number. This atomic number is already given in the periodic table. Atomic number means it's the number of protons, which are equal to the number of electrons, which are equal to 12. Okay? So we are going to distribute the electrons based on the octet rule, 2, 8, 8, 8. So we are going to put in the first level 2, second 8, and in the third Yes, we are going to put only 2 because magnesium is only 12. Okay? Let's practice more. Okay. What is that? So it came here. Okay. So here are some questions. Okay, those are questions from past papers. And always in every lesson, we are going to make this practice. So I want you to solve those questions. We are going to solve them together. When I ask you to label that, you're going to look here. As I said before, the small number is the atomic number. The big number is the mass number. So you will start writing here the atomic number and the mass number. While here, this is the chemical symbol for sodium. Again, you are going to complete what is the number of protons in the atom. I want you to think deeply. If you got the answer, yes, it's 11. And then, what is the number of protons and neutrons? If you got the answer right, it will be 22.9 or 23. What is found in the center of the atom? Who is smart enough to tell me and has a good memory? Yes, it's the nucleus. While which one is the negative charge? It's the electron. Yes. Okay, let's go to this. This is also from a past paper. What is the name of the particle X? I'm sure all of you know it right now. Yes, it's the electron. What is the number of particles in the nucleus of this phosphorus atom? It's very easy. I'm going to count them. Number of particles, all of it, I'm going to count it. And definitely, I'm going to find it most probably 30. Try to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, yeah, almost 30. You're going to count them all and you are going to write your answer here. Again, another question from another past paper. So write down the name of part A. I'm sure all of you now are super and you can tell me that this is the nucleus and B are the electrons. What is the charge of B? The charge of the electrons are always definitely negative. This question, it's going to be a homework for the next session. And not only this, there's a worksheet that will be posted for you on the atomic structures that you need to complete and practice on. It's going to be very important. And when you submit your homework, it will be corrected and I will give you my feedback on that. Thank you.